Hi, this is Ideal Gas Law Part 2. So we will be taking a look at the formula for the ideal gas law, and again, some additional input into how the ideal gas law was formulated from based on the other gas laws. So if you remember, again, we have four variables in a gas: pressure, volume, number of particles, and temperature. And please take note that out of the four basic laws, we combined three of them, Boyle's, Charles, and Gay-Lussac's law, into the combined gas law. And this is how the combined gas law looks like. And again, in your case, you might be saying, sir, we have the Boyle's law, we have the Charles's law, we have the Gay-Lussac's law, and then we kind of combine them into the combined gas law. How about the Avogadro's law, sir? It's kind of like left behind because when we combine Boyle's law, Charles's law, and Gay-Lussac's law, we kind of we have the combined gas law, but the Avogadro's law is left behind. Well, this is the Avogadro's law, which is V1 over N1 is equal to V2 over N2. And guess what? When we combine this combined gas law and the Avogadro's gas law, we get the ideal gas law. Okay, so again, let me repeat that. If we take Boyle's law, Charles's law, and Gay-Lussac's law, combine them together, we get the combined gas law. Obviously, Avogadro's law is left behind, but if we add Avogadro's law into combined gas law, you take the ideal gas law. So therefore, the ideal gas law is kind of like the combination of all the four basic laws that we have. Okay, so how does that work? Well, again, we take what's our technique in kind of combining Boyle's law, Charles' law, and Gay-Lussac's law, and look at this. And if we combine this, if you notice, the V1 here is in the numerator. The V1 here is also in the numerator. So we just kind of say, okay, P1, V1, and then over T1. And then N1 here is in the denominator. So we have to put that here, N1. Okay, that's in the left side, right? If we combine these things in the right side, then we have P2, V2, and again, there's no conflict because remember here, V2 is above in the numerator. V2 here is also above in the numerator, so there's no conflict. So I can just put V2 there, and then T2 here is in the new denominator. But if you notice N2, there's no N2 here, but N2 here is in the denominator, so I can just put that here. And that's it. You got the ideal gas law. Right? So you got the ideal gas law. So P1 V1 is over N1 T1 is equal to P2 V2 over N2 T2. So this is kind of the raw kind of formulation for the ideal gas law. But actually, this can even be simplified. This can even be simpler. And however, for us to understand why it can be simpler, we have to kind of go back into the Boyle's law, right? So what is Boyle's law again? Or just go back to one of the laws, and in this case, let me just choose the Boyle's law. So for example, Boyle's law, remember in Boyle's law, we are looking at P versus V, but we keep N and T constant, okay? So the Boyle's law, if you really think about it, is really um, a shortcut of the ideal gas law. Because if you think about it, if you keep N and T constant, so therefore this N and T disappears. And guess what? If it disappears, you get Boyle's law. Right? If we are looking at Charles's law is about V versus the temperature. And guess what? We keep the N and the pressure constant. So if you have the ideal gas law formulation, all you need to remember is, okay, I need to remove N and P. Guess what? If you remove N and P, that becomes V1 over T1 is equal to V2 over T2. What is that? That is exactly Charles's law, right? And then if you have Gay-Lussac's law, you're looking at P versus T, and then you're keeping again N and V constant. So what does that mean? You just simply need to erase V and n, because they are constant after all. So what does that give you? That gives you P1 over T1 is equal to P2 over T2. And guess what? That is Gay-Lussac's law. Okay, so this is what I'm telling you, that it pays to kind of connect them together, because after all, they are really connected and they're supposed to be studied like that. They're not supposed to be studied in isolation. And if you look at the last law, which is the combined gas law, PVT, and then you keep the n constant, that means all you need to do is delete the n from the equation, and guess what? That's P1 over V1, P1 V1, P1 times V1 over T1 is equal to P2 times V2 over T2. So what I'm trying to say is, you don't even have to memorize Boyle's law, Charles's law, Gay-Lussac's law, and combined gas law. All you need to really do is remember the ideal gas law, and then remember conceptually that, okay, if I'm dealing with Boyle's law, it's looking at pressure and volume. So therefore, I erase everything else. So if I erase everything else, you get the formula for Boyle's law. P1 times V1 equals P2 times V2. It is as simple as that. And again, if you understand the connections of these laws, you study smart. You don't study hard, right? You study by, you don't memorize it brute force and memorize the P1 V1 equals V2 V2 T1. What's the use of that if you don't get the underlying connection? So again, the law, if you really think about it, the only reason why we discuss Boyle's law first, because it's simpler, right? It takes a look at two formulas. And in fact, in history, that's how it was done. Boyle's law was discovered, and then Charles's law. Then when they knew about all these laws, they combined it, making the combined gas law, and then they conceptualized more and making the ideal gas law. But now that we know the ideal gas law, we can do it backwards. We can just remember the ideal gas law, and we can kind of get the Boyle's law from the ideal gas law without having to memorize 4 separate equations. You just memorize this equation, and you just have to understand what variables are investigated in Boyle's law, in Charles's law, in Gay-Lussac's law, and in combined gas law. But that is the idea. Okay, that is the idea. You can kind of get what is the Boyle's law, what is the Gay-Lussac's law, what is the Charles's law, what is the combined gas law, just if you remember the ideal gas law and kind of think about things logically. Okay, so that's a tip, because a lot of times I see students kind of memorizing the gas laws and kind of making mistakes because they don't have a coherent approach at understanding the gas laws. This is how you understand the gas laws. This is how you look at it from a framework that all of them are connected. And again, you can just kind of get what the gas laws are, what the smaller gas laws are from the ideal gas law. So that would be the objective for this video. In the next video, we will discuss more about why this is not the format of the ideal gas law that is kind of in the books. There's another simpler format than this, and we will explain why it becomes simpler.